So this is the last chapter test that you guys are going to take. This is for chapters 7 and 9 for the 8-week course. Okay, so these chapters were pretty dense, right? A lot of information in there, a lot of individual steps to take. So we're going to go over a few things before we dive into the questions themselves. So as usual, if you want a recording of this, if I've sent you a recording before, then I will send it to you again. You don't have to provide your email again. But if you have not joined us before and you want me to send you a recording of this review after it's done, you can either put your email in the chat or you can email me directly asking for the link to the recording. And I'll give you my email address at the end. I'm Maxine Horn. I am Learning Specialist here at the Academic Sports Center, and we are going to dive in. Okay, so a few things that I want to go over. There are lots of things that you guys need to know how to do on the calculator, and there are a lot of sort of general things that you need to make sure that you know how to do. So I've just written down that this is not necessarily an exhaustive list, but I've written down lots of things that I feel like you guys should be comfortable with. So I'm going to refer back to this sheet as we do these problems. So things like, okay, how do I find an area under a curve given the z-score? How do I find a z-score given the area under the curve? How do I find a critical value given the alpha? How do I find the p-value and the standardized test statistic when my population standard deviation is known, or when it's not known, or when I have a proportion? And then with things related to correlation, there's a lot of buttons to press on the calculator. So we will go through that part in more detail. Okay, so like I said, just kind of a few things that I just want to go over before we dive into this. So hypothesis testing, you guys want to make sure that you're comfortable with understanding how to translate the English to the math, how to write your hypotheses in the math symbols, given that it was provided to you in an English sentence. You want to make sure that you understand that the null hypothesis, H sub 0, is always the one that has some sort of equality. And the alternative hypothesis is always the one that has a strict inequality, right? So this is equal, not equal. Less than or equal to, just less than. Greater than or equal to, just greater than. And you need to know which ones correspond to the other, which ones are complements of the other, right? So if you have a claim that says something is equal, then you need to know that your other hypothesis is going to have to be not equal to. If you have a claim that is greater than or equal to, you need to know that your other claim, or that your other hypothesis, is going to be less than, and then so on and so forth. There are lots of really helpful charts in the textbook that I would suggest that you maybe rewrite in your notes or take pictures of or something like that. Sorry, hold on, let me make sure this is okay. You guys can see that big, right? That's taking up mostly the whole screen for you. Okay. So this is one of those charts. So this is the difference between the type 1 and type 2 error. So the type 1 error is when you've rejected the null hypothesis, but it was true. The type 2 error is when you didn't reject the null hypothesis, but it was false. The check marks is you selected the right thing. Also knowing that the type of test that you have, whether it's left-tailed, right-tailed, or two-tailed, is based on your alternative hypothesis. So if your alternative hypothesis is less than, and you're over on the left, less than. If your alternative hypothesis is greater than, it's right-tailed. And if your alternative hypothesis is not equal to, then it's two-tailed. something we're going to keep coming back to is this decision rule based on the p-values, because it tends to be kind of the fastest way to do many of these, just because the calculator allows us to find these values very quickly. So knowing that when you go to compare your p-value with your alpha, that if your p-value is less than or equal to alpha, you reject the null hypothesis, right? You're always either rejecting the null hypothesis or failing to reject the null hypothesis. Those are your two options, right? Once you do that, then how you word it is in this chart down here. So while I know that this chart at the bottom here looks kind of overwhelming, if you do enough of these problems, I promise it'll get easier for you to kind of notice the pattern, right? So you'll notice that here, if we're rejecting the null hypothesis, we're saying that there is enough evidence to do something. If we're failing to reject the null hypothesis, we're saying that there's not enough evidence. If the claim was your null hypothesis, then we're talking about rejecting the claim. But if your claim is the alternative hypothesis, we're talking about supporting the claim. So that's kind of how these things all interact. Like I said, I know it looks like a lot. The more you do them, the more kind of intuitive it's going to become. And like I said, we'll continue to refer back to these pages as we do these problems, but just making sure you're comfortable with the symbols. So you guys already know your sample standard deviation and your population standard deviation, your sample mean, your population mean, and then we have our correlation coefficient, the R and the rho. Also, just a reminder, as with previous chapters, if you know your population standard deviation, you're going to be using a z-score. And if you don't know your population standard deviation, you're going to be using a t-score. And then again, as with previous chapters, if we're dealing with proportions, we're going to be using a z-score. And then we've got kind of the two ways that we can look at, I shouldn't necessarily have said or here, but you know, different ways that we can look at correlations. Okay, so let's dive right in. A brewery claims that the mean amount of beer in their bottles is at least 12 ounces. Determine whether the hypothesis test for this claim is left-tailed, right-tailed, or two-tailed. Okay, so the first thing you're going to do is you're going to write out in symbols what the claim was. Okay, so they said that the claim was that the mean amount of beer in their bottles is at least 12 ounces. So at least means greater than or equal to 12. Okay, so you want to make sure that you're comfortable with all the different ways that you can describe greater than or equal to. You could say 12 or more, you could say at least 12, but you want to make sure that you're comfortable with taking the language and turning it into the symbols. Okay, so once you write down your claim, what you're going to do is you're going to say, okay, well, I need to have a null hypothesis and I need to have an alternative hypothesis. Okay. So remember that the null hypothesis is going to be the one that contains some kind of statement of equality. So either equals or greater than or equal to, less than or equal to. The alternative hypothesis is going to be a strict inequality. Okay. So once you've written down what the claim is, you have to decide, well, did I just write a null hypothesis or an alternative hypothesis? So this symbol has some kind of statement of equality. So that means that this is the null hypothesis. Okay. And I always like to write next to it which one was the claim. So it's not always the null hypothesis, it's often the alternative hypothesis, but in this case, it happened to be the null hypothesis. So now we need to write the alternative hypothesis. So going back to this sheet here, okay, so the null and the alternative hypotheses are, you can think of them as complements of each other, right? So if you have an equal sign, the complement of that is the not equal. what we have is a greater than or equal to, so the complement of that is less than. So in our other hypothesis, in this case, our alternative hypothesis, we need to have a less than. So the mean is less than 12. Okay. All right, now why did we need to come up with the alternative hypothesis? Because the alternative hypothesis is what you use to determine if it's right-tailed, left-tailed, or two-tailed. So again, pulling this up. The type of test is based on your alternative hypothesis, not the null hypothesis. Okay, so our alternative hypothesis is less than 12. So that's going to be left-tailed. Right? So alternative hypothesis tells us that we are left-tailed. So this shaded area is the p-value, and the value that separates the shaded area from the not shaded area is the standardized test statistic. So, but all they're asking for in this one, is it left-tailed, right-tailed, or two-tailed? It is left-tailed because that's based on the alternative hypothesis. And we came up with the alternative hypothesis because it is the complement to the null hypothesis. Okay. So, like I said, a lot of steps in these problems. The more you do it, the easier it becomes. Okay. All right. Okay, what are the two types of hypotheses used in hypothesis tests, and how are they related? So we've just talked about this, right? So this one is the null, and this one is the alternative. And I really should write my A's like that so that they're they're not as confused, not as easy to confuse with the O, but I just kind of emphasize the little tail on my A to make sure I don't accidentally glance at it and think that it's a 0 instead of an A. And then how are they related? Like I said, they are complements, right? If remember, complements are they add together to one, right? Or you can think of it as you know, it's either, like for instance, the one we just did. We were saying that the mean was greater than or equal to 12. So the only other option that we have is less than 12, right? So it's either one or the other. And 100% of the values are either going to be greater than or equal to 12, or they're going to be less than 12. It's going to be one or the other, and together they make up 100%. Questions like that, hopefully not too bad. Okay, describe the two types of errors possible in a hypothesis test. All right, so let's pull this back up here, our little error chart here. Okay, so a type 1 error is when the null hypothesis is true, but instead of not rejecting it, we did actually reject it. Okay, so a type 1 error occurs if the null hypothesis is rejected when it's true. Right? It was true, but we rejected it. That's an error. That's a type 1 error. Type 2 error, this other type of error, occurs if the null hypothesis is not rejected, but it's false. So it was false, but we didn't reject it when we should have. So that's the type 2 error. All right, use the given statement to represent a claim. Write its complement and state which is the null and which is the alternative hypothesis. So again, very similar to kind of what we did in that first one, right? So, except we got to skip the step of translating the English to the math. They're saying, hey, the claim is that the proportion of something is less than 0.34. So remember that the null hypothesis is the one that has some kind of equality the alternative hypothesis has strict inequality. Okay. All right. So we need to determine which one of these should this be written under. So this has a strict inequality. So it is the alternative hypothesis. So I'm going to go ahead and write it next to the alternative hypothesis. Okay, so write down what the claim is, then decide which one of these it is. Remind yourself that that's the claim, and then determine what the other one is. So if the alternative hypothesis is less than, then our null hypothesis needs to be the complement of that, which would be greater than or equal to. Right? So remember the complements here. The complement of less than is greater than or equal to. Okay. So, yeah, so I mean, I don't really need to circle this, it's already circled. So our null hypothesis is that the proportion is greater than or equal to 0.34 because our alternative hypothesis, which was our claim, was that the proportion is less than 0.34. Okay, it says, right, it's complement. Okay, that's its complement, and state which is the null and which is the alternative. And then, oh, it's having you, right, so the complement of the claim is that symbol, right? So I kind of skipped over this, but we did it over here. If this is the claim, this is the complement of it. Okay. All right, given that the null hypothesis, hey, that's great. They told us right away what the null hypothesis was, is that the mean is greater than or equal to 18 and P is 0.067. Do you reject or fail to reject the null hypothesis at the 0.05 level of significance? So we are using our decision rule based on p-values, right? We're going to compare the p-value to the level of significance, to the alpha value. And we are going to either reject the null or fail to reject the null. Okay, so let's take a look at these two things. So we have the null hypothesis is that the mean is greater than or equal to 18. Okay. We don't have to find the alternative hypothesis here, but if we wanted to, we could do that. That's not required because really we just need to know that this is the alpha, the level of significance is 0.05, and that our p-value, it went ahead and found it for us, is 0.067. Okay, so is this value less than or equal to alpha, or is it greater than alpha? So this value is greater than alpha, so we're going to fail to reject the null hypothesis. Okay, you see that? P-value is greater than the alpha, which is the level of significance, so we're failing to reject the null hypothesis. So we're just going to keep coming back to this decision rule. And eventually you'll just have it memorized because you'll have looked at it so much. Okay, you wish to test a claim that the mean is less than or equal to 29. I'm going to go ahead and write that down. The claim is less than, whoops. I always forget the eraser on the back of these pencils. It's not that great. The claim is that the population mean is less than or equal to 29. Okay, at a level of significance of 0.01, and we're given some sample statistics. Okay, so we are told that n is 40, and the sample mean is 30.8. Okay. Assume the population standard deviation is 4.3. And they want us to compute the value of the standardized test statistic and to round our answer to 2 decimal places. Okay, so first thing we're going to do is look at our null hypothesis and our alternative hypothesis. This is our claim. We need to decide, is that the null or is it the alternative? So the null hypothesis is one that has some type of equality in it. So this one happens to be the null hypothesis. Again, it's not always your null hypothesis, right? One of the ones that we did the claim happened to be the alternative hypothesis. But in this case, our claim is the null hypothesis. Okay, so our alternative hypothesis is now mu is greater than 29. So remember, the alternative hypothesis is what tells us what type of test we have here. This is a right-tailed test because it is greater than 29. Okay. So the p-value is this shaded area, and the number that separates your non-shaded from your shaded area is your standardized test statistic, which is what they're asking us to find. Okay, so there's two. Where's my case? There we go. So there's a couple of ways to find this. Okay, so they might want you to use the formula. Probably not. Whoops, don't know why I just wrote X. I probably don't want you to use the formula, but it's good to know that the formula exists. But what you can use instead is your calculator, right? So we know, let's see if I can put all of this on here, right? We know our population standard deviation. We were given that. So we know that. So we're going to do a z-test because that's going to give us, it's going to give us a lot of things. It's going to give us the p-value and the standardized test statistic. So how do we do that? We go to stat. We go to tests. You can either arrow to the right twice, or if you arrow to the left, it like loops around and goes over to the right to tests. And it's the very first one, z-test. All right, so we're going to input all of the information that we were given in this problem. Okay. Also, we're going to do it with stats rather than data. Okay. All right, so 29 is the population mean. Population standard deviation is 4.3. The sample mean is 30.8. The N is 40. And then this is a right-tailed test. So we're going to go over here and we're going to select right-tailed. Okay, and then we're going to calculate. Okay. So we get the Z. That Z is our standardized test statistic. Okay. The P, that is our p-value. Okay. But they just asked for the standardized test statistic and they wanted it rounded to 2 decimal places. Quick reminder for rounding, 2.647488274. We round to 2 decimal places. I like to underline the number I'm rounding to. Look to the number to the right. If this is 5 or more, this goes up 1. If this is less than 5, this stays the same. This is 5 or more, so this goes up 1. Okay. I always say you never want to get a question wrong because you rounded wrong or because you typed in, the number wrong or anything like that. So always, kind of check your work as you go, check to see if your answer makes sense, check to see if what you're plugging in makes sense. Okay, so again, if you want to use the formula, you can. It's just often much faster to just plug this into the calculator. Again, we are using when population standard deviation is known, that is a z-test, which we get to with stats tests, and then one z-test. Looks like a 7. It's not, it's a 1. Okay. Number 7. Okay, the p-value for a hypothesis test is shown. Use the p-value to decide whether to reject the null hypothesis when the level of significance is, and then they give us 3 different options here, right? Because you might want to test something at different levels of significance. These questions get pretty lengthy. Okay, so remember our decision rule based on p-values, right? You've got to remember that. Okay. So, okay, it's telling us that our p-value is 0.0373. Okay, so for A, we're comparing that to an alpha of 0.01. For B, we're comparing that to an equals to an alpha of 0.05. And then for C, we're comparing it to an alpha of 0.1, just 0.10. One right back. Okay. So for the first one, 0.0373 is greater than this. Okay. And what does the rule say? It says that if the p-value is greater than the alpha, then we fail to reject the null hypothesis. We fail to reject the null hypothesis because the p-value is greater than the alpha. Okay, for the second one, it's 0.05 is our alpha. So our p-value is less than the alpha. So less than or equal to, if the p-value is less than or equal to alpha, we reject the null hypothesis. So there we go. Reject the null hypothesis because the p-value is less than alpha. And then the last one, 0.10. This is definitely less than that. So if we're less than alpha, we reject the null hypothesis. Okay. Always come back to your charts, your notes, whatever it is. But again, you'll probably end up memorizing this if you do enough homework problems with it. Okay, number 8. Use the calculator displays to the right to make a decision to reject or fail to reject the null hypothesis at a significance level of 0.1. Okay, I shouldn't have unfolded that because we're right back at it, right? Okay, so if our p-value, here's our p-value, okay? There's a lot going on here, right? But our p-value is 0.296478888. And they want us to compare that to a level of significance, an alpha, of 0.10. So this is greater than that. It's greater than the alpha. So we're going to fail to reject the null hypothesis. So since the p-value is greater than the alpha, we fail to reject the null hypothesis. Okay, several steps to this one. So test the claim about the population mean at the level of significance alpha. Assume the population is normally distributed. So that's important if our n value is not 30 or more, right? If n is less than 30, then we need to make sure that it's normally distributed for us to be able to do all this stuff with it. So it's okay if it's not normally distributed as long as our n is greater than or equal to 30. But in this, it happens to be both, so good for us. Okay, so we have a claim. The claim is that population mean is greater than or equal to 1474. So we need to identify the null hypothesis and the alternative hypothesis. So remember, the null hypothesis is the one that always has some type of equality in it, whereas the alternative hypothesis is always a strict inequality. So that means that this has to get written here because it has some type of equality in it. And then again, I always like to identify which of these is my claim. Okay, so if that's my null hypothesis, my alternative hypothesis is going to be the complement of that. So remember, the complement of greater than or equal to is less than. Right? Null hypothesis has some kind of equality. Alternative hypothesis is a strict inequality. Okay, the alternative hypothesis is what tells us what type of test we have. This is less than, so that is going to be left-tailed. And let's go ahead and write down everything else they told us. All right, so they gave us an alpha of level of significance, alpha of 0.02. And they also told us that the population standard deviation is 29. So that tells us which menu we're going to use in the calculator, the fact that we do have a population standard deviation, right? This is telling us that we're going to be using z-scores rather than t-scores. Right, like if we, real quick, let's go back to this. Right, remember, if we know our population standard deviation, we're going to use a z-score, whereas if we don't know our population standard deviation, we're using t-scores. Okay, so we do know our population standard deviation, and then it gives us some of our sample statistics. We've got our sample mean is 1468, and our n, our sample size, is 30. Okay, so the first thing that it wanted us to do was to identify the null and alternative hypotheses. Well, we already did that, right? We said that our population mean greater than or equal to 1474, that was our claim. So the alternative must be that the mean is less than 1474. Okay, so now it wants the standardized test statistic and the p-value. So again, you can do these by hand using your your formulas and looking things up in the chart in the back, or you can have your calculator do it. Right? So we are looking for when our population standard deviation is known, we want to find our p-value and the standardized test statistic, which is z. We're going to use a z-test. So stat tests 1 z-test. So I'm going to go stat. Oops, move this up a little bit here. Stat test, and the very first one, z-test. I can either hit enter or I can hit 1. Okay, and now I'm going to plug all of this information. Okay. So again, we're doing stats rather than data. Our population mean is 1474. Our population standard deviation is 29. Our sample mean is 1468. And our sample size is n, 30. And this is a left-tailed test. So we're going to make sure that that's selected, less than, right? Because remember, what goes here is your alternative hypothesis, right? Because the alternative hypothesis is a strict inequality, and this is strict inequalities. Okay, and then we go calculate, and we get our information here. So again, our z is our standardized test statistic. That is this value right here. This z-score is negative 1.13 if we round to 2 decimal places. And then the p-value, which is the area to the left of that z-score, is right here, 0.12856, blah, blah, blah. They want us to go to 3 decimal places. So again, our rounding rules, 3 decimal places. We look to the number to the right, That's 5 or more, so that goes up 1. So that's how we get 0.129. Okay, great. But now we have to interpret it, right? We have to decide, are we rejecting the null or failing to reject the null? And then we have to put that into words. So again, we come back to our decision rule based on p-values. Okay. So we're going to compare our p-value with our level of significance. So this 0.129 is greater than 0.02. So that means we are failing to reject the null hypothesis. Okay, so let's write that out. I'm going to say fail to reject the null hypothesis. Okay, so now let's look below that. So we failed to reject the null. So now we say, okay, well, was our claim the null or was it the alternative? So in this case, our claim was the null hypothesis, and we are failing to reject it. So we're failing to reject the null hypothesis, and our claim is the null hypothesis. So where do those two intersect? Right here. So the way that we have to word it is that there is not enough evidence to reject the claim. Right? We failed to reject the claim. There's not enough evidence to reject the claim. So fail to reject the null hypothesis. And then remember, when you're writing out these statements, there's always going to be this part where we specify, hey, specifically at the 2% level of significance, at the 2% level of significance, because we could have a different outcome if we change the level of significance. So we have to specify at the 2% level of significance, there is not, oh, you can't see that. There is not enough evidence to reject the claim. We're not saying we accept it. We're just saying we can't reject it. We fail to reject it. There's not enough evidence to reject it. Okay. These charts are a lifesaver. Okay, use technology to help you test the claim about population, papers out here. Population mean mu at the given level of significance alpha. Using the given sample statistics, assume the population is normally distributed. Okay, and then if we look at our sample size, we don't have to rely on it being normally distributed because our n is greater than or equal to 30. So that's nice. Okay, so we're going to do the same process we did before. We're going to say, okay, what's the claim? And that's where we're starting. The claim is that our population mean is less than or equal to 1250. Okay. We're going to figure out if our claim is a null hypothesis or if it's an alternative hypothesis. So the null hypothesis always has some type of equality. The alternative hypothesis is always a strict inequality. So that means that this has to go here. And again, I always like to remind myself which one's the claim. Okay, so that's our null hypothesis. So our alternative hypothesis is the complement of that. So it's going to be greater than 1250 because the complement of less than or equal to is greater than. Okay, so let's write some of the other information that they gave us. And they told us that the level of significance that they want us to use is 6%, 0.06. They did give us that the population standard deviation is 199.31. And then they gave us the sample statistics, that the sample mean is 1282.15, and the sample size is 200. So let's go ahead and draw what this looks like. Remember, the alternative hypothesis is always the one that tells us what this looks like. This is greater than, which means this is a right tilt test. So again, the p-value is the area under the curve in the shaded region, and the value that separates the shaded from the non-shaded is the standardized test statistic. Okay, so that's kind of your first step all the time, right? Is get everything written down, right? Write your claim. Determine if your claim is your null or your alternative. Whichever one it is, find the other one. Write down all the other information they give you. Draw your distribution, draw your graph based on the alternative hypothesis. Remind yourself what these things are. You don't have to label them. I just like to. Okay, so now let's go through and let's actually answer what this is asking for. Okay, identify the null and the alternative. Okay, well, we did that over here. That was like the first thing we did, right? The claim happens to be our null hypothesis. Again, it's not always the null. It's just as often the alternative as it is the null. And then they want us to, like some of the other problems before, they want us to calculate the standardized test statistic and the p-value. So again, if we go to our calculator sheet, we were given a population standard deviation. It is known. So if we want to find our p-value and our standardized test statistic, we're going to do a z-test. Okay, that's what we do. So we're going to go stat, tests, and the first one, z-test, and we're going to input all the information they give us. Okay, our population mean, 1250. Our population standard deviation, 199.31. Right? Yeah, 199.31. Okay. Our sample mean, 1282.15. Our sample size, n, and this is greater than. This is a right-tailed test. It is greater than. And calculate. Okay, so we have our standardized test statistic is our z, and then we have our p-value is the p, again rounded to 3 decimal places. Okay, determine the outcome and the conclusion. So again, we want to be comparing our p-value with our alpha, just because this is just most often the just the fastest way to do it. So our p-value was 0.011. Our level of significance is 0.06. Our p-value is less than our alpha. If our p-value is less than or equal to the alpha, we're going to reject the null hypothesis. So let's write that down, that we're going to reject the null. Okay, so we know we're going to reject the null, so let's talk about how we write that. We're going to reject the null. Okay. Was our claim the null or was it the alternative? It was the null. So we're rejecting the null and the claim is the null. So we're going to say that at a 6% level of significance, there is enough evidence to go ahead and reject the claim. Okay. So we reject the null at the 6% level of significance. Right, that's our alpha, 6%. There is enough evidence to reject the claim, right? We rejected it. We say there is enough evidence to just reject it based on our chart down here, our decision chart. Hold on just a moment. I am recovering from a cold, so if my voice gets a little rough, that's why. Okay. For 11, a nutritionist claims that the mean tuna consumption by a person is 3.2 pounds per year. A sample of 90 people shows that the mean tuna consumption of that sample by a person is 2.9 pounds per year. assume the population standard deviation is 1.19 pounds at a 7% or a 0.07 level of significance. Can you reject the claim? Right, so we're going to go through and we're going to calculate all this, right? So they're saying this nutritionist is claiming that the mean consumption is 3.2 pounds per year. So they're claiming that the mean consumption is 3.2. So we have to, we have to say, okay, is that our null or is that our alternative? So remember, the null hypothesis has some type of equality in it, whereas the alternative hypothesis always has a strict inequality. So this has equality, so that would make it the null hypothesis. So then we have to do the complement of that for the alternative hypothesis. So the complement of equals is not equals. Right? Okay. And then we were given a bunch of other information, right? We were given that our alpha, or our level of significance, is 0.07, 0.07. We were told the population standard deviation. We're not always given that, but we were here, 1.19. Okay. And then we were given sample information. The sample mean was 2.9. And the N, the number of people in the sample, was 90. Okay. All right. So we're going to draw what this looks like based on the alternative hypothesis. When we have a not equals, that means that we have a two-tailed test, right? So remember that each of these sections individually is just half of P, right? You have to add both of these up together to get the full P value. If you're given the full P value, each of these is half of that, okay? 1/2 of the P value. This is 1/2 of the P value. And then your standardized test statistic, the positive one's going to be over here, the negative one's going to be over here. Okay. All right, so let's go ahead and plug this into the calculator, right? So again, we were given our population standard deviation, which means that it's known. It's known. We're going to do a z-test. We go to stat, tests, and the first option, z-test. We're going to do stats. Right? Our the number that's with our claim, right? You can just kind of think of it like that, right? Our population mean, 3.2. Population standard deviation, 1.19. Sample mean, 2.9. Sample size, 90. And then this was two-tailed. Right? We have to change it to not equal to, because remember, what we put here is what the alternative hypothesis is. And calculate. Okay, so it's giving us this one over here, right? Because it's always thinking like area to the left, right? So it gave us this negative 2.39. There's also this 2.39 over here. But that's what it's giving us, the negative 2.39. And then it's giving us the full p-value. Okay, so not half of the p-value, but both of those together added up. The p-value is 0.01. And if we round to 3 decimal places, right, that's going to be 0.017. Okay, so we have our p-value. Let's remind ourselves what our level of significance is, 7%. So our p-value is less than our level of significance. What happens when our p-value is less than or equal to our alpha, we're going to reject the null hypothesis. So I'm going to go ahead and write that down. I know I'm going to reject the null. And then I remind myself, okay, I'm rejecting the null. Now, was my claim the null or the alternative? In this case, it was the null. So I am rejecting the null, and my claim was the null. So we're rejecting the null, and we're saying, yeah, there's enough evidence to reject the claim. So we reject the null, and there is sufficient evidence to reject the claim. And what was the claim? The claim was that the mean tuna consumption is 3.2 pounds at this level of significance. Okay. So you see how we're always coming back to this chart, right? So one step at a time. When you look at it all at once, it seems a little overwhelming, but when you take it one step at a time, each step leads you to the next step, right? I compared my p-value to my alpha. That told me whether I rejected it or failed to reject it. Okay, so I rejected it. Then I said, okay, well, now I need to know which column I'm looking in. Was my claim the null or was it the alternative? Well, I just look back at what I wrote and I say, oh, that's right. I wrote that the claim was the null. So the claim is the null. So where do these two intersect? This right here. Okay. Right. Find the standardized test statistic, T. Okay, we haven't done one of those yet. For a sample with n equals 15, sample mean is 3.9, sample standard deviation is 0.8, alpha or level of significance is 0.05. If your null hypothesis is that the mean is less than or equal to 3.6, and round your answer to 2 decimal places. Okay, so a lot of information they gave us there, right? So we are going back to our things here, right? When we don't know the population standard deviation, but we need to find the p-value and the standardized test statistic, which is going to be a t, we're going to use a t-test, which is in the same place as the z-test. It's just number 2 instead of number 1. It's the t-test. Okay. But we need to make sure that we have all of our information to plug into the calculator. So let's do our standard operating procedure here. We're going to write everything out. We're going to say, okay, well, actually, you know what? They didn't say what the claim was. They just told us that the null hypothesis is that the mean is less than or equal to 3.6. And the alternative hypothesis we have to come up with, that's going to be the complement of this. So that's going to be greater than 3.6. The alternative hypothesis is what determines what type of test we use, right-tailed, left-tailed, two-tailed. This is greater than, so this is a right-tailed test. And let's go ahead and write everything else they gave us. They want a level of significance of 0.05. And they gave us the sample size is 15. Sample mean is 3.9. The sample standard deviation is 0.8. Okay. All right, so again, in the calculator, we are going to go to stat, tests, and we're going to go to number 2, the t-test. Also, a note here, if you're doing this by hand, don't forget that your degrees of freedom with t-values are n-1. All right, so we have our population mean. We have 3.6. If our sample mean is 3.9, our sample standard deviation is 0.8, our sample size is 15, and this is a right-tailed test. It's greater than. Okay. So it's p-value, and this is our standardized test statistic, which is the t, which is all they're asking for here, rounded to 2 decimal places, 1.45. So in this one, they're not having us do quite as much as the other ones. So not that we were using it here, but if you were wanting to do this by hand, degrees of freedom is n minus 1. All right. Number 13, use the t-test to test the claim about population mean at the given level of significance, alpha, using the given sample statistics, assume the population is normally distributed. So I didn't mention that here, but I'm going to go ahead and assume that they want you to assume that this one was normally distributed, because our n is less than 30. Anyway, okay. So again, we're going to say, okay, what's my claim? Okay, so we've written the claim. Now we need to determine, is the claim the null hypothesis or the alternative hypothesis? Your null hypothesis has some type of equality, whereas your alternative hypothesis is always a strict inequality. Okay, so that means that this happens to be your null hypothesis. I know we get a lot of these where the claim is the null hypothesis, but it's not always. So we need to come up with the alternative hypothesis, which is the complement to this, which is less than 7,900. So our alternative hypothesis is what determines what our graph looks like. Less than, so this is left-tailed. Okay. Let's go ahead and write everything else they gave us. We have a level of significance, an alpha of 5% or 0.05. And our sample statistics that we were provided is that the sample mean is 7,600, the sample standard deviation is 430, and our sample size is 24. Okay, so the first one we've already answered, right? Our null hypothesis was the claim, mu is greater than or equal to 7,900. The alternative hypothesis is the complement of that, less than 7,900. Okay, so now we're going to move on to finding the standardized test statistic and the p-value, which again, we can do when the population standard deviation is unknown. We do that using a t-test, which is stat test number 2. So we're going to go stat test, t-test, and we're going to input all the information we were given under stats. So the number related to the claim, again, you can think of it like that, but it's essentially this null hypothesis, 7,900. The sample mean was 7,600. Sample standard deviation, 430. Sample size, 24. And then our graph is left-tailed, it's less than. Our alternative hypothesis is less than, and calculate. Okay, so we have our standardized test statistic, which remember is this value right here. That's a t-value of -3.42 if we go to 2 decimals. And then the p-value, which is the shaded area, that's equal to 0.001 when we round to 3 decimal places. Okay, so we're going to compare and I don't always rewrite this, but if you find it helpful, go ahead and rewrite your level of significance right next to your p-value if it helps you to compare them. We want to compare, is the p-value less than or equal to alpha, or is it greater than alpha? So this p-value is less than this alpha. So that falls into this, less than or equal to alpha, which means we're going to reject the null hypothesis. So again, one step at a time, I'm going to go ahead and write down, reject the null hypothesis. And then I'm going to say, okay, I'm going to reject the null hypothesis. So I'm looking at this row here. I need to know, was my claim the null hypothesis or was my claim the alternative hypothesis? So I go back up to what I wrote here, and I wrote that my claim is my null hypothesis. So I rejected the null hypothesis, and my claim is the null hypothesis. So that means there is enough evidence to reject the claim at this level of significance. Okay. So it says here, reject the null hypothesis, and at this level of significance, at 5%, there is enough evidence to reject the claim. Right? We're either saying that there is or there is not, and we're either saying that we reject the claim or we support the claim. So I've got those words in bold. All right. Number 14, test the claim about population mean at the level of significance alpha. Assume it's normally distributed. Okay. So again, got our claim is that the mean is less than 50-15. We're going to say, okay, did I just write a null or did I write an alternative hypothesis? The null hypothesis has some type of equality. The alternative hypothesis has a strict inequality. Well, that's a strict inequality. So this one is actually the alternative hypothesis. There we go. I knew we would get one of those again eventually. So this is our claim. We need to now identify our null hypothesis. It's going to be the complement of this. So the complement of less than is greater than or equal to. Okay. We're going to use our alternative hypothesis to say what this looks like. This is less than, so this is a left-tailed test. Let's go ahead and write everything else they gave us. They want a level of significance of 10% or 0.1. Our sample statistics are that the sample mean is 5117. Our sample standard deviation is 5725. And our sample size is 53. Okay, so our, oh yeah, this one, it kind of writes it funny. So the null hypothesis is that the mean is greater than or equal to 5115. And our alternative hypothesis is that the mean is less than 50-15. Okay, so now they want us to find the standardized test statistic and find the p-value. So again, how to do that? When our population standard deviation is unknown, we use the t-test, stat test number 2, p-test. Okay. So we go stat test number 2, t-test. Okay, so we're going to fill in the information we know. The population mean 50-15, sample mean 5117, sample standard deviation 5725. Goodness, that's a big standard deviation. And an N of 53. Okay, and again, this is your alternative hypothesis. So that's less than. So that was already selected just from the last one that we did. And we say calculate. Okay, so our standardized test statistic, if we round to 2 decimal places, this t, right, that's your test statistic, is 0.13. and your p-value is 0.551, again, if you round to 3 decimal places. So p-value is 0.551. We're going to compare our p-value to our level of significance. Again, if you want to write it next to here, you can. Our p-value is greater than our alpha. So we say when our p-value is greater than our alpha, we fail to reject the null. Okay, so we're going to write that down. We're going to fail to reject the null. Okay, and then we say, okay, and then was our claim the null or was it the alternative? Right, so fail to reject the null. And then I need to know if my claim is the null or if my claim was the alternative. So I go back up here and I say, okay, my claim was the alternative. So my claim was the alternative hypothesis, and I failed to reject the null. So we're going to say that there's an E at the end of there, is not enough evidence to support the claim. Right? There's not enough evidence to support the claim. So the way they have these filled in is weird. There is not enough evidence at the 10% level of significance to support the claim. And then, yeah, fail to reject. We already said that. Okay. So make sure that you've got this, go to in your textbook. I forget what page that's on, but that chart is in your textbook. This decision rule based on p-values, I noticed that they actually have it in a couple different places. One place where they first introduce it, and then they remind you later when you go to use it again. They're like, hey, don't forget, this is the rule. So you should see these in your book in a couple of places. So make sure that you've got that in your notes because you guys can see how often we're referring back to these, right? Yeah. All right. Number 15, use a t-test to test the claim about population mean, the given level of significance, alpha, using the given sample statistic. Assume it's normally distributed. Okay, it's good because our n is only 13. Okay, again, claim is that mu is not equal to 24. You need to say, did I just write a null hypothesis or did I just write an alternative hypothesis? Null hypothesis has some kind of equality. Alternative hypothesis has a strict inequality. That's a strict inequality. So we just wrote the alternative hypothesis. The null hypothesis is going to be the complement of that. The complement of not equal to is equal to. The alternative hypothesis tells us what our graph looks like. This is two-tailed, right? Not equal to is two-tailed. And remember that these shaded regions, when added together, are our p-value. We're going to write down everything else they gave us. They gave us a level of significance of 0.01. They gave us our sample statistics of 26.8 is our sample mean. 4.4 is our sample standard deviation. And our sample size is just 13, but that's okay because it's normally distributed. So we don't have a population standard deviation, so we're going to use the t-test again. So we go stat, test, t-test. We're going to put in the data that we have, or the stats that we have. So our null hypothesis, the number that we have there, our population mean 24, our sample mean 26.8, our sample standard deviation 4.4, our sample size 13. This is a two-tailed test. We have not equal to. So remember, this is always your alternative hypothesis. And if you forget that, that's okay, because this is only going to display the things that you'll have written in your alternative hypothesis. And then calculate. Okay. So our p-value if rounded to 3 decimal places, is 0.041. And our test statistic is 2.29. Keep in mind that's this right here, 2.29, but this over here would be just negative 2.29, right? This is just on the other side, reflected. Okay, so we have our p-value. So remember, we're going to compare that to our level of significance. So our p-value is greater than our level of significance, our alpha. Our p-value is greater than our alpha, so we're going to fail to reject the null. Okay, we're failing to reject the null. Now we have to say, was our claim the null or was it the alternative? Our claim was the alternative. So if our claim is the alternative and we failed to reject the null, then that means that there's not enough evidence to support the claim. Right? So we failed to reject the null when there's not enough evidence to support the claim at the 1% level of significance. Do enough of these, gets to be a little bit easier, right? Okay, number 16. So now we're dealing with proportions, okay? So a couple things for proportions. Remember that your p hat is equal to your x over your n. Sometimes you're just given your p hat directly. Sometimes you're given your x and your n individually, but you want to make sure that your sample proportion is your x over your n. Okay. Okay. So a research center claims that 28% of adults in a certain country would travel into space on a commercial flight if they could afford it. In a random sample of 1,200 adults in that country, 32% say that they would travel into space on a commercial flight if they could afford it. At a level of significance of 1% or an alpha of 0.01, is there enough evidence to reject the research center's claim? And we're going to complete each of these parts to do it. So, yeah, we're just going to go through and do this much like the others. I'm going to say, okay, there was a claim. Well, what was their claim? The research center claimed that 28% of adults would travel into space on a commercial flight if they could afford it. So they're claiming that the proportion is 28%. That's what they're claiming. All right, so now we have to say, well, did we just write a null or did we just write an alternative hypothesis? The null hypothesis has some type of equality. The alternative hypothesis has strict inequality. Well, this is some type of equality. It's an equal sign. So that is the null. So our claim happens to be the null. So we're going to go ahead and write what our alternative hypothesis is. It's the complement of that. Complement of equal is not equal. Okay. Right. So they're saying, hey, we're saying this is 0.28. And the alternative is it's not 0.28. It's anything besides 0.28. It's everything above and everything below, but it's not 0.28, right? Okay, so that tells us, the alternative hypothesis tells us what type of test this is, right-tailed, left-tailed, two-tailed. Not equal to is two-tailed. Okay, so let's write everything else they gave us. So they said that they gave us an alpha of 0.01. Okay, in a random sample of 1,200 adults. Okay, so that's our n. Our n is 1,200. Excuse me, just a second. Okay, so they gave us our n, and then they said 32% say that they would do this. So that's our sample proportion. That's our p hat. It's 0.32. So we didn't have to calculate that ourselves, right? They didn't tell us like how many out of the 1,200. They just gave that to us. Okay. Okay, so Now, so going back to our calculator sheet, for a proportion, we want to find our p-value and our standardized test statistic, which remember is the z. Go back to this sheet here, right? Our population parameter, population proportion. P hat is our sample proportion, and our standardized test statistic is a z. So for a proportion, we're going to do one prop z test. So that's in the same place that all the other ones were, stat tests, but this time we go down to number 5. And then I just wrote this here. Don't forget that your p hat is x over n, because sometimes you might have to remember that relationship depending on what you're given. Okay. So let's go to our calculator. And we're going to go to stat, tests, and then I can either arrow down to 5, one prop z test, or I can just hit number 5 and it'll just go straight there. All right. So our null hypothesis, our population proportion is 0.28. And then it's asking for the x and the n. We weren't given an x and an n, were we? We were given that p hat is just 32%. Well, that's okay. We can find x. There's a couple different ways you can think about this. You can kind of think about it algebraically, and you can say this up here. You can say, well, if p hat equals x over n, then I have 0.32, which is p hat, equals x over, and n is 1200. And then you can solve this equation algebraically. So to get the x by itself, I'm going to multiply both sides by 1200, right? X is being divided by 1200. So to get rid of the division, I'm going to multiply. What I do to one side of the equation, I do to the other. Multiplying and dividing cancel each other out. On the right side of the equation, I just have x. On the left side of the equation, I have 1200 times 0.32. Or if you don't like thinking of it like that, what you can do is you can say, well, the sample proportion is 32%, right? So I want to know what 32% of 1200 is. Well, all I have to do is multiply 0.32 times 1200. And you know what? I can just do that right here in the calculator. I don't have to actually calculate it. I can say 0.32 times 1200 and say, hey, calculator, can you please do that for me? And it does. Excuse me. 384. So again, just to show you what I did, I typed in 0.32 times 1200 because this is 32% of 1200. So 0.32 times 1200. And when I arrow down, it says, oh, here, let me do that math for you. It tells me that my x is 384. Okay, so now I'm going to fill in the rest of the data. I have 1200 here. And then this is not equal to, right? It's a two-tailed test. So we need to make sure that the not equal to is highlighted. And then we're going to go down and we're going to calculate. So again, this test statistic, this z-score, remember, is 3.0, well, I guess 09 if we go to 2 decimal places. And then over here is negative 3.09, right? Because we've got positive, we've got the negative. All right, so the p, remember this p, hold on, make sure my pencil is showing up the same way on the screen as it is in front of my eyes. This p right here is not p hat, right? It's telling us what p hat is, in case we didn't already know it. This is our p-value. This is the area in the shaded regions, both of them added together. So our p-value is 0.002. Okay, so now we're going to, excuse me, we're going to compare that to our alpha, to our level of significance, which was 0.01. So our p-value is less than our alpha. Okay. There we go again with our sheet. Okay, so if my p-value is less than my alpha, I'm going to reject the null. All right, so we're going to say reject the null. me. And now that I know that I'm rejecting the null, I have to say, okay, well, what was my claim? Was it the null or the alternative? So I go back up here and I say, okay, my claim was the null. So I go to my table and I say, I'm rejecting the null and my claim is the null. So where those two intersect is that there is enough evidence to reject the claim. So there is enough evidence to reject the claim. Also, we just said we rejected the null hypothesis. And I'm sorry, I just kind of skipped over this first part where it wanted us to identify the claim and state the null hypothesis and the alternative hypothesis. So, excuse me, the claim in this scenario is what they set up here. What the research center claims is that 28% of adults in the country would travel into space on a commercial flight if they could afford it, right? That's what they're claiming. That's what our claim is. That's what we labeled the claim. That's what we labeled the claim. Okay. We came up with the claim. We said, okay, our claim is our null hypothesis. So our alternative hypothesis has to be the complement of that. Okay. Then we used the calculator to find both the standardized test statistic and the p-value. We compared the p-value to the alpha, excuse me, in order to determine if we're going to reject the null or fail to reject it, but we rejected it. And then we used our chart to determine, based on whether we're rejecting or failing to reject, and whether our claim was the null or the alternative, that tells us how we're allowed to word our conclusion. We have to be very careful with how we word the conclusion. Okay. Excuse me, I apologize for coughing directly into the microphone there. All right. Number 17. Humane Society claims, what's their claim? Is that less than 70% of households in a certain country own a pet. Their claim is the proportion of people who own pets is less than 70%. In a random sample of 600 households in the country, 402 say they own a pet. Well, that's going to be our X value, right? So in a minute, we're going to find out our p hat, which is X over N. Excuse me just 1 second. Get a cough drop. While I do that, see if you guys can maybe start working ahead on this one. Okay, I apologize if my voice is going to sound kind of weird because I've got a cough drop in my mouth, but I think that is better than the alternative of me continuing to cough all over you. Okay, so I know I didn't really give you a lot of time to get started here, but okay, let's keep going. They gave us an alpha of 0.01, and they want to know, is there enough evidence to support the society's claim? So I kind of just started writing stuff down here rather than doing my normal process. You can write stuff down first, that's fine. But let's go ahead and do what we got to do over here. So the claim was that the proportion of households in a certain country that own a pet is less than 70%. So less than 0.7, that's our claim. All right. We have to determine if that is a null hypothesis or if that is an alternative hypothesis. So the null hypothesis contains some type of inequality, and the alternative hypothesis contains a strict inequality. So this is a strict inequality, so that's going to be the alternative hypothesis. So that's our claim. So now we can write our null hypothesis is going to be the complement of our alternative hypothesis. The complement of less than is greater than or equal to. Okay. Our alternative hypothesis is what shows us what type of graph we have. This is less than, so this is a left-tailed graph. Okay, so now let's come over here and let's actually put these numbers in. Excuse me. Still coughing anyway, sorry about that. Actually, you know what? I'm not going to do that because the calculator doesn't require that I do that. Because this is so again, back to our calculator, this is a proportion. So we're going to find the p-value in the standardized test statistic by doing one prop C test, which is stat, test, and then go down to number 5. So I'm going to go stat, test, down to number 5. And I don't actually need to know p hat. It's going to calculate that for me. Okay, so my null hypothesis, the number related to that, the population proportion, is 0.7. Our x value is 402. Our n, our sample size, is 600. This is a less left-tailed test, less than, and we're going to calculate that. All right, so our z-score, so remember that right there, our test statistic, our z-score, is negative 1.60, if we go to 2 decimals. And our p-value, that area there that's shaded in, and that's our p-value, is equal to this p right here. Right now, it did give us the p hat in case we wanted, sorry, right there, the p hat, where I look at it, that's not where the pencil is. Anyway, so 0.67. So if we had plugged that in, we would have gotten 67%, 0.67. All right, so our p-value is 0.054. Do we want 3 decimal places? Yeah, they said 3 decimal places. It's really hard for you guys to see that. It's so green. Oh, it's just the reflection. Yeah, 3 decimal places. Okay, so that's our p-value. Okay, great. We've got our p-value. Let's go ahead and compare it to our level of significance, our alpha, which is 0.01. Our p-value is greater than our alpha. You know the drill by now. If our p-value is greater than our alpha, we're going to fail to reject the null. P-value is greater than the alpha, fail to reject the null. Okay, and then we say, okay, great. Well, great. It's a relative term. Maybe that's what we wanted. Maybe it's not. But we're failing to reject the null. We need to just say, okay, what was our claim? Was our claim the null or was it the alternative? Our claim was the alternative, and we failed to reject the null. If our claim is the alternative hypothesis and we fail to reject the null, then we would say there's not enough evidence to support the claim. Okay? It's not enough evidence. There is not enough evidence to support the claim, this particular society's claim, right? Because we failed to reject. Okay, let's go back up and actually answer the questions that they've asked here. So, identify the claim, right? We did that up here. Less than 70% of households in the country own a pet. And then state your null and your alternative hypothesis. We did that here. Null. Well, let's start with the alternative because that's what our claim was. P is less than 0.7. So the complement is greater than 0.7, greater than or equal to, sorry, 0.7. And then we used the calculator to find our p-value and our standardized test statistic. We compared our p-value to our level of significance to tell us whether we failed to reject or rejected the null, right? And remember, it's always in relation to the null. You're never rejecting the alternative or failing to reject the alternative. It's always, do you reject the null or fail to reject the null? It's always in relation to the null. Then you use this, this result and combine that with the information of, is the claim the alternative or is it the null, to determine how we're allowed to word our conclusion. All right. Okay, so now we're jumping into chapter 9. Okay, so remember for chapter 9, and I didn't write a bunch of stuff on the sheets for this, I guess, but we do have a bunch of stuff that we're going to have on the calculator. Okay, so which of the following values could not represent a correlation coefficient? So your correlation coefficient is between -1 and 1. It can be as low as -1 and it can be as high as 1, right? Your R value can be anywhere in between there. But it can't be more than 1 and it can't be less than -1. So this is not quite 1. This is 0. So that's fine. 0's in between there. This is -1. Yeah, it's allowed to be these barrier numbers, but it can't be more than 1. Okay. So remember, if you have a graph, and actually, you know what? No, I'm not even going to do the dots. Let's say all your dots perfectly line up like that. Okay. Or you graph them and they perfectly line up like that. And the slope of this line is 1, right? So every one you go up, you go right 1, 1, 1. And then the other way around here, every one you go right, you go down 1. Every one you go right, you go down 1. The R for this is 1. The R for this is -1. So this has a super strong positive, right? Positive correlation. This has a super strong negative correlation. If you've got a bunch of dots that are just like all over the place, then there's really not much correlation, right? So your R might be kind of close to 0, right? So the closer you get to 1, the closer you are to having a really strong positive correlation. The closer you get to -1, the closer you are to having a really strong negative correlation. But when you come into 0, right, because you kind of picture like a number line, right? Like here's -1, here's 1, and where's 0? 0 is directly in the middle. So if you go this way, if you get close to this, it's really strong. If you get close to this, that's really strong. But if you get close to the middle, then there's not a strong correlation, right? Kendra, yes, I will email you the recording. Absolutely. Yeah, we're almost done. Well, almost done is a relative term. We're into the chapter 9 stuff. So yes, I will go ahead and email that to you. I'm glad they've been helpful. That's good. Okay, so yeah, so that was number 18. All right. Now for number 19. So calculate the correlation coefficient for the data below. Now, excuse me, it's my understanding that they do not need you to do this by hand. Okay. The formula for doing this by hand is kind of long and involved. It's not super difficult. It's just really time intensive. Okay. So like I said, it's my understanding that they just are okay with you just doing it on the calculator. So let's talk about how to do this on the calculator, because there are several steps to this. Okay. All right. So the first thing that we have to do is we have to actually put that data into the calculator, right? This is going to be in one column and this is going to be in another column. You want to make sure that your X is in like the first column, and that your y is in the second column. Now, I don't mean specifically first and second, but it could be like, you know, the third and the fourth or something. Now, I went ahead and ahead of time, I programmed all these numbers into specific columns in my calculator just to save time so that I'm not plugging it in, you know, while we're trying to work through this. So what I did in my calculator, and I don't know why I jumped to L5. I must have had other stuff in there, but I had this is L5 and this is L6. So you don't have to do L5 and L6. You can do L1 and L2. But how do we put it into our calculator? So if you remember back to chapter 1, or maybe it was chapter 2, we're going to go to stat. Can't see that. Excuse me, stat, and we're going to edit. We're going to edit some numbers. Now, like I said, I am in list 5 and list 6. Okay. So there's my list 5. So here's all of these X values, right? -3, -1, 6, so on and so forth. And then L6, I've got my Y values. Okay. And they may write these different ways. They may have kind of these horizontal lines. They may have vertical lines. They may just have like a table. You've probably seen several different ways that they can present this data to you. But one set of numbers goes in one list, one set of numbers goes in another. And make sure you know which list they're in. Okay, so once you've put the numbers in, right, you went to stat, edit, and you input the values into the 2 columns. Now what we're going to do is we're going to do the linear regression t-test. Okay, so we're going to go to stat, test, right, same place that we were going for other tests, but this is all the way down at F, linear regression t-test. So I go to stat, tests, and I can either arrow all the way down, 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 down to F, or if I go stat tests, I can arrow up and it takes me to the bottom of the list and F is closer to the bottom. Or another way is I could just do the letter F. So on my calculator, the letter F is in yellow above the cosine button. So I can hit alpha cosine and it'll do F. So I'm going to say alpha cosine and it did F. All right, so what do we put in here? So your X values are wherever you put your X values. So in my case, I put it in L5. So your calculator, you have L5 is just above button number 5. So you're going to do second and then 5, or maybe in your case, you're going to do L1. So you're going to do second 1. And then second 2, or in my case, second 6 for L6. Okay? Because that's where my X and my Y are. Right? You have to tell it where to look. Where are my X's? Where are my Y's? Now, the frequency for everything you're doing in this class, you just leave that at 1. Okay, we're not telling it any list to look at. Just have the number 1 there. Sometimes I think for most calculators, if you leave nothing there, it gets angry. So you have to have 1. Like I said, you're not going to worry about in this class which one that's for. Okay, now for right now, we're not worried about which one of these it is. Okay, for right now, don't worry about that. Now, for regression equation, for some problems, you don't need to worry about this, but I'm going to go ahead and suggest, just so that you get in the habit of telling it to put this equation, because what it's going to do is it's going to calculate an equation. You can tell it, hey, plug that equation that you calculate for me into a specific place. We want to plug it into Y1. Okay, so how do we do that? Well, that's what I have written right here. The regression equation, what you're going to do is you're going to say, okay, Y is a variable, so I need to go to vars, variables. Okay, I'm going to go to vars, I'm going to hit the vars button. And I'm going to go to wait, what did I do here? Oh yeah, I'm sorry. I forgot to put a step in here. y vars. Sorry, you have to do y vars next. So you're going to hit the vars button, which is right here. Okay. Then you're going to arrow over to y vars, and then the first option there, function, this is a function, you're going to hit enter, and you're going to select y1. Telling it, hey, I want you to put that equation into y1. And then you're going to arrow down, and you're going to say calculate. And it's going to give you a bunch of information. Okay, so we're going to wait to talk about these other things until we get a problem that goes over that. Okay, for right now, let's just look at what we have here. They want us to tell them the R, the correlation coefficient. So there's a lot of information here. Right? Remember that your equation, and the calculator is reminding you that your equation is y hat equals a plus bx. Keep in mind, normally we actually rearrange those. X plus a, we put this term first, right? But anyway, so it's telling us what our a value is, right? Told us the a value. It told us the b value, okay? And then the little arrow over here tells me to go down, that there's more information down there. And if I scroll down, I can see that there is an R value right there. And it gives me an R value of 0.98965458222. And I'm going to round that to 3 decimal places because that's what my answers go to. This is 5 or more, so it makes this go up 1. But this is already 9, which means this has to go up 1. Right? This has to go up 1, and then this is going to go to 0. 989, super close to 990. This is point. Okay. So that's how we find the correlation coefficient, is we plug the data into just stat edit. Then we go to our linear regression t-test, which is stat, test, all the way down to F. If you want, you can go ahead and tell it where to put that equation. But if you're not worried about it for that particular problem, you don't have to do that. You can just go stat, test, linear regression test, plug in what you have, and then hit, I think it was calculate. Okay. All right, the data below are the number of absences and the final grades of 9 randomly selected students from a stats class. Calculate the correlation coefficient R. Okay, so let me go back to my notes and see which list I put these in. So I put these in L1 and L2. So if I go to stat and then edit, that's where I'm going to put them in. So I go to L1 contains my X values. L2 contains my Y values. Okay. Then we're going to go to our linear regression t-test. So it's in the same place as the other tests that we were doing earlier in the day. So we're going to go to stat, test, but I want to go all the way down to the bottom, linear regression t-test. Okay, so again, I have to tell it which lists to look at. So my calculator L1 is right here above the 1. So I'm going to go second 1, and then list 2, second 2. Again, leave that as a 1. Right now, we're not worried about this. You can leave it as whatever you want. For this problem, I'm not worried about having a Y1 there. And then calculate. So again, it's giving us a bunch of information. And there we have our R value, negative 0.991 if we go to 3 decimal places. That's really, really close to -1. That means a really strong negative correlation, right? Didn't really talk about that in the last one, but what does this R value mean? This R value means that I have a really strong positive correlation. The dots are like super close around that line. This one is really close to -1. So I've got a really strong negative correlation. Those dots are really close to a line with a negative slope. Okay. 21. Which value of R, okay, yeah, this is what we were just talking about. Which value of R indicates a stronger correlation? 0.832 or negative 0.947, and explain your reasoning. So it didn't ask about negative or positive, it just asked about stronger. Because remember that, let me get for one first talking about these. Remember what we said about if we get closer to either -1 or 1, it gets really strong. But if we're close to 0, then it's not very strong. A way that you can compare them to R values is to just say, well, how far away from 0 is it? And how do we find how far away from 0 a number is? We take the absolute value of it, right? So if you forgot from your algebra class, these symbols mean the absolute value. So if I have the absolute value of 3, that means how many units away from 0 is 3? Well, it's 3 units away. So it's like distance without direction, right? Because the absolute value of -3 is also 3, right? They're both 3 units away from 0. This distance is exactly the same as this distance. We don't care which direction we're going. We just care how far we went. Okay? All right, so when we want to compare to see which R value has a stronger correlation, we're going to compare their absolute values. Okay, so we're going to compare 0.832, the absolute value of that, which is just 0.832, right? It's already positive. We're going to compare that to the absolute value of -0.947. So remember, how do we take the absolute value of something? Just make it positive, right? Just ignore the sign. Whatever sign you have, just ignore it. Just make sure that it's positive. 0.947. So which one of these is closer to 1? This one is closer to 1, so it has a stronger correlation. They didn't ask about negative or positive correlation. They just wanted which one has a stronger correlation. This one has a stronger correlation, right? This has a stronger correlation because the absolute value of it is more than or is closer to 1 than the other number, right? On a number line, here's 0, here's 1, here's -1. If we're looking at the absolute value, here's 0.947 and here's 0.832. 947 is closer to 1, and the closer that we get to the 1, the stronger the correlation. Okay. Okay. 22. What does it mean to say correlation does not imply causation? List a pair of variables that have correlation but no cause and effect relationship. Okay, so you might not know this about me, but I actually have a degree in psychology. And if they taught us nothing else in our research classes, is that correlation does not equal causation. Even if you have a very, very strong correlation, there could be all sorts of reasons for that. It does not mean that one thing causes another, okay? The classic example that a lot of places taught, and I was actually surprised that I didn't see this in the book, this particular example. Maybe it was in one of the homework problems. I didn't do all the homeworks. Is if you look at a graph of the murder rate and the number of ice creams sold, they have a super, super strong, very, very strong positive correlation. their correlation coefficient is almost 1. It's super, super strong. The amount of ice cream people are buying is not causing people to murder more. People murdering more is not causing people to buy more ice cream. Those two things are absolutely correlated, but neither of them causes the other, right? There is another, I forget the name of the other factor. They call it like an unknown factor or something like that, or a third factor that is at play here. So oftentimes it's literally just the hotter it is outside, the more violent crime there is. And the hotter it is outside, the more ice cream people buy. So ice cream does not cause murder, and murder does not cause people to want ice cream. Okay, so correlation. Remember, if you take nothing else away from a research class, is that correlation is not equal to causation. Just because there's a correlation does not mean that one thing is causing the other. Okay. All right. Rant over. Okay, so what does it mean to say correlation does not imply causation? The fact that two variables are strongly correlated does not in itself imply a cause and effect relationship between the variables. Okay. And then which of the following pairs of variables have a correlation but no cause and effect relationship? The number of school buses at a school and the number of teachers at a school. Yeah. I mean, there's other factors at play here, right? But one of them is not causing the other. Just because I have a bunch of buses doesn't mean that the number of buses is going to cause me to have more teachers. And the number of teachers that I have doesn't cause me to have more buses. There's another factor that kind of ties together the relationship between these things, because there is correlation, is that if you have a lot of students, right? If you have a lot of students, you're probably going to have more buses. And if you have a lot of students, you should probably have more teachers. I mean, depending on what your child to student to teacher ratio is. But these two things in themselves, one does not cause the other. So sometimes things are correlated because there is a connection that kind of makes sense. And sometimes things are correlated and there's a connection that absolutely has, I don't want to say has nothing to do with either of them, but means that these two things have nothing to do with each other. Okay. All right. The scatter plot of a paired data set is shown. Determine whether there is a perfect positive linear correlation, a strong positive linear correlation. Right, so is it perfect positive linear, strong positive linear, perfect negative linear, or strong negative, linear, I meant to underline linear, not negative, correlation, or no linear correlation between the variables. So real quick, let's just talk about what are they talking about there. So perfect positive linear correlation would be the dots are exactly on the line. Whereas a strong positive linear correlation, they're pretty close, pretty close. Perfect negative is the dots are all exactly on the line. Strong negative is the dots are pretty close. They're pretty close to the line. Or no linear correlation. So there's clearly some sort of relationship happening here, right? We've got a shape here, right? But it's not a line, right? Line, linear. These are linear relationships, linear correlations. This is not linear. It's something, but it's not linear. That's why there's no linear correlation. It doesn't mean that there's not some type of relationship. It just means that it's not linear. We're dealing with linear in this section. Okay. All right, find the equation of the regression line for the given data. So again, we're going to be using our calculator, right? We're going to plug these numbers into stat edit. right, into two lists. And then we're going to run a linear regression t-test to find the values. Okay, what values are we going to find? The calculator is going to give us a plus bx. It's going to give us an a and a b. We have to remember that we have to write it in this order, right? The b goes before the x and the a is separate. So this might look familiar to some of you who have taken an algebra course recently. The equation of a line, y equals mx plus b, where m is your slope and b is your y-intercept, right? It's similar to this. We're not really going to think about it like that necessarily, though, because you don't want to confuse yourself with this b value, right? This right here is your slope, and this is your y-intercept. Okay, so let me go back to my notes, see which lists I put these in. Okay, so I said that I put this as list 3 and this is list 4. So I'm going to go to stat, edit, I hit enter, and then you're going to put in whichever list you want. It doesn't have to be the one that I've done, but there's my x values. I put in list 3. I go over to list 4. Here are my y values. Okay, so now we're going to go to stat, tests. I'm going to go up so that I can quickly get to linear regression t-test. I'm going to tell it which lists to look at. What were my x's? My x's were in list 3, so I'm going to say second 3. My y's were in list 4, so I'm going to say second 4. Remember, you always want your frequency to just stay at 1, just leave that at 1. And then it doesn't matter which one of these we use for now. And then, so let's go ahead and make sure, if you're following along with me, go ahead and put that y1 there. So a quick reminder of how to put that y1, because I'm going to show you how that might help us in a minute here. So to put that y1 there, with your cursor in that section, you're going to go vars, variables, right? You're going to go to y vars, y variables. You're going to go to function, first option, and we're just going to select y1. And then calculate. Okay, so it's giving us a lot of numbers. We're looking for the b value and the a value. So right here is our a value. Okay, our a value is negative 0.552 if I go to 3 decimal places. And then our b value is right below it. Our b value, if we go to 3 decimal places, is 2.097. Okay. All right, so we have our a and b. We're going to do this 2 ways. We have our a and b. Now we're going to rewrite this equation. So we have y hat equals, and instead of b, I'm going to write what we found b to be. 2.097 times x plus, except I don't want to say plus because a is negative. I mean, I could say plus. I could say plus a negative 0.552, but adding a negative, when we simplify that, that's just subtracting, right? So this is my b, right? This is my b. This is my b. This is my a. This is my a. Negative 0.552. That's my a, right? See that relationship there? You see how we're just taking the b, plugging it in where the b is written, taking the a, plugging it in where the a is written. And conveniently, the calculator reminds you, well, I mean, it does say a plus bx, but remember we write the b x before we write the a. So bx plus a. Okay. Now, remember I said that we're going to put in that y equals. So now what we're going to do, here's my calculator. So now what we're going to do is we want to see the equation. right? The calculator created an equation for us. We want to go ahead and see that. So to see it, we're going to hit the y equals button. So on the calculator, the y equals button is right up here in the top left. So I'm going to go ahead and hit that, y equals. And there it is. It looks kind of messy because of two reasons. One, it's in that other format, right? It's in this a plus bx, and it is not rounded, right? It's giving me as many decimal points as it can display, right? So remember the a value, which is what it's giving me here to start out with, it's starting with the a, is this 0.552, right? I would round that to 552. And then I arrow over and it says plus, and then a big number, x. Not a big number, but a number with lots of decimal points after it. 2.097x. So if you feel like this is too hard to read, that's fine. Don't worry about it. Just stick with, okay, they gave me the B is the thing that goes in front of the X. They gave me the A is the thing that goes afterwards. Okay? Or if you can kind of see through all the decimals here, you can feel free to go up to y equals to see the equation itself. Again, you have to both see through all the decimals and also remember that it gives you this in this order, and we actually want to rearrange these two terms. We want the bx to come before the a. Okay. Okay, 25. We're getting there. The data below are the temperatures on randomly chosen days during a summer class and the number of absences on those days. Find the equation of the regression line for the given data. So same type of thing, right? So let's see, what list did I put these in? So I went all the way to, I created a list 7 and list 8. I'm not going to tell you how to do that. That you guys won't need to do that. Your calculator is not going to show a list 7 and list 8, and we're not going to worry about how to do that. But you're going to go to Stat and Edit, and in preferably list 1 and list 2, you're going to put your values. If you have things in the list, I think I've already used list 1 and list 2. Oops. If you have things in the list, remember that you can clear the whole list by making sure that you're highlighting the top of it. So not in it, but at the top of it, you hit clear and then enter, and it will clear the list, right? Go to the top of it, clear and enter, and it clears the list. Okay, so I put these numbers in L7 and L8. Just double check that that really is. Yes, that looks right. That looks right. Okay, so we did stat, edit, to put the numbers in a list, make sure we know which lists we're putting them in. Then we're going to go to stat tests, and we go all the way down to linear regression t-test. F. We're going to tell it which list we were in. So I am L7 and 8. Again, you want your frequency to just stay at 1. We're not changing that in this class. For right now, it doesn't matter which one of those you're choosing. If you want to make sure that the y1 is there because you want to look at the equation, you can. And the steps to do that, we would hit vars, then go to yvars, number 1 function, and y1, if you wanted to be able to see the equation. But if not, then you can leave that blank and then calculate. So it's going to give me, remember we have bx plus a. That's our formula. So our b is equal to 0.449 if we go to 3 decimals. And a, right, so a is on its own. B is stuck to the x. So even if you're rearranging these, just make sure that the b is always stuck to the x, right? Okay, a is negative 30.27 if I go to 2 decimal places. So when I go to write this, I'm going to say y hat equals e 0.449 x plus, this is negative, so I'm just going to go ahead and write minus, instead of writing plus a negative, 30.27. And that's how we get the equation. Right, number 26. Given that the equation of the regression line is blah, what is the best predicted value for y, given that x is 3.8? Assume that the variables x and y have a significant correlation. If they don't have a significant correlation, then this is useless, right? Not useless, but useless for our purposes. So again, thinking back to algebra, you have an equation with two variables, okay? You have an x and a y. If you're provided one of those values, you can find the other one, right? You can just plug in the x and then clean this up and solve for y. So that's exactly what we're going to do. It's telling us that x is 3.8. So I have negative 1.5. Remember, when the number is right up next to the variable, that means multiplication, right? So it's being multiplied by, and I always like to put my numbers in parentheses if I'm plugging them in, plus 1.2. So when I go to plug this into the calculator, I'm going to say negative 1.5 times, or I could put it in parentheses if I wanted to, 3.8 plus 1.2. And I get negative 4.5. So y hat equals negative 4.5. Right? If I have the independent variable of 3.8, the dependent variable that depends on that is negative 4.5. Okay? All right. The data below are the temperatures on randomly chosen days during a summer class and the number of absences on those days. What is the best predicted value for y given x equals 81? Assume that the variables x and y have a significant correlation. Okay, so let me go back to my notes and see what lists I put these in. Oh, that's right. This is exactly the same set of values as this one, right? It's the same numbers. So we've already done half the work for this problem, because the first thing that you have to do is you have to plug this into a list. I did list 7. You have to plug this into a list. I plugged it into list 8. You have to do stat edit to plug it into the list. Then you have to go to stat tests, linear regression t-test, to get this information to come up with your equation. It's the same set of data, so we get the exact same equation. So my equation here, even though they didn't give me the equation, I have to find the equation in order to then plug in a value, right? Once I have that equation, I can plug in a value. They're saying, hey, tell me what the y is when an x is 81. So let's go ahead and do that. When x is, oh, I don't know why I wrote directly on one there, minus 30.27. Right, so again, we did half the work already in this other problem because it was the exact same data set. So if this wasn't the same data set, we would have to do these steps. Stat edit to plug them in, stat test linear regression t-test to get this information to come up with the equation. Once you have the equation, then you can plug in an x value. Okay, so come up with your equation first, then you can plug it in. You can plug the x in to get the y. So 0.449 times 81 minus 30.27. And that's how we're getting, I mean, you know, rounding here, 6. Okay. All right. Explain how to predict y values using the equation of a regression line. Well, that's what we've been doing for the last 2 problems, isn't it? We've been substituting a value of x into the equation of the regression line. And then we've been solving for y, or y hat, right? Promise, we're almost done. In order to predict y values using the equation of a regression line, what must be true about the correlation coefficient of the variables? It has to be significant, right? So if it's not significant, then we can't make assumptions, we can't do calculations. If the correlation between the variables is not significant. All right, and then this one is, I believe, our last one. We got a lot going on in this one, so it's actually, it's on 2 pages, but I literally could not make it fit on 1 page and still be legible. It was like way too small. So, okay, they're having us do a lot of things here, right? So, they want us to find the equation of the regression line for the given data. You know what? Let's start there, even before we do anything. Let's do that. So I have to, let's see, I put this in, I created L9 and L10. That's what I did. Again, my suggestion is always do like L1 and L2. Nice and easy. So you're going to go to Stat, Edit, put your numbers into L1 and L2, or in my case, L9 and L10. Right? My X's go in the first list, my Y's go in the second list. Okay? Then I'm going to go Stat, Tests. I'm going to go all the way down to the bottom so that I can go to F, which is Linear Regression T-Test. I'm going to tell it which lists to look at. L9 and L10. Yours is probably going to be L1 and L2. Again, leave your frequency at 1. For the purposes of this, it doesn't matter which one of those we're choosing. If we want the equation there, then we can go ahead and, you know, follow those steps that I had here about how to put that in to Y1 and then calculate. Okay, so we have y hat equals dx plus a. So we have 0.041, right? Are we going 3 decimals? Yeah, we're going 3 decimals. X, and then my a value is a positive, so I can write plus 20.6, what's that, 612? Okay, they just want 2 decimals. And so 6.1. Okay, great. Here is my equation. All right, find the equation of the regression line for the given data. Done. Regression equation, there it is. Right, this is your B value, this is your A value. Okay. Remember, the B is what is stuck to the X. So even if you rearrange these, you're fine as long as your B is what's stuck to your X. Okay. All right. Then it says, then construct a scatter plot of the data and draw the regression line. And it's telling us, hey, you're allowed to do this because the pair of variables do have a significant correlation. Then use the regression equation to predict the value of y for a whole bunch of different x values, if meaningful, which we'll talk about the meaningful part. And the table below shows the numbers themselves. Okay, so plotting the regression line. So go back to our, and remember this is our calculator sheet where we've got all the different things that we're going to do on the calculator here. Oh, I forgot about this. Okay, if you've been doing some of these problems and you just keep getting them wrong, you might need to turn your diagnostic on. Okay, it might already be on in your calculator, but if it's not on, you need to turn it on. Okay. If you've been having trouble with these problems and you're like, I'm doing what it says to do, why am I getting the wrong answer? You might need to turn your diagnostic on. So how do I turn my diagnostic on? I go to second, you're going to go to catalog. On my calculator, catalog is at the very bottom above the 0. So I'm going to go second catalog, and it takes me to this super long list. And I'm going to go all the way down to diagnostics. All right, so we've got diagnostic off and diagnostic on. I want diagnostic on, so I'm going to make sure the arrow is next to diagnostic on, and I'm going to hit enter. And then I'm going to say, oh, whoops, I didn't mean LN. Hold on. Must have accidentally hit that. Okay, diagnostic on, and then I'm going to hit enter again. And the calculator says, okay, we've made sure diagnostic is on. So make sure you've done that. If you keep getting wrong answers and you don't know why. Or if you keep getting like an error message, I forget what it tells you if your diagnostic is not on. All right, so I know that this is kind of blurry. I'm not really sure why. But anyway, in order to graph it, so we've already done this. We've already stat, edit, put the stuff in. We have probably already done the linear regression test. When we did the linear regression test, we made sure to put y1 into, hey, where do you want your regression equation? I want it in y1. Okay, so now what I'm going to do is I want to graph this. Okay, so I'm going to go to, oh, did I actually do that? I don't remember. Yeah, 9 and 10. Okay, so yeah, so I did. I told it y1. So now what I want to do is, in order to graph it, I'm going to go to second y equals, because above the y equals is stat plot. We're going to plot some statistics, right? We're going to go to y equals stat plot, and we're going to use number 1, plot, or plot 1 on. So let's do one thing at a time. I'm going to go to second y equals, so that's where stat plot is. Now on mine, it says on. Yours might say off. That's okay. We can turn it on. We're going to hit enter since it's highlighted on number 1. And we're going to make sure that that on is selected rather than off, right? Make sure on is selected. Okay, then what you want to do is you want to select this first option here, right? This is the scatter plot. And you have to tell it what your X values are and what your Y values are. Now it's already got 9 and 10 in here because I was already creating the linear regression t-test. So it's like, oh, hey, do you want to use the same stuff you were just using a minute ago? Why, yes, calculator, thank you, I do. And then you might say, okay, well, where's the calculator? Where's the graph? It's not here. Then you have to go to Zoom. Now, this might seem weird, but the way that you can remember this is that the calculator is going to automatically zoom to the location on the graph where all these data points occur, right? Because we want to be able to see this set of data, not like picture like if you zoomed out really far, you'd be like, wait, where's all my points? Oh, wait, they're, that tiny little section over there. It's going to zoom in to show you just the data points that you have, right? So that's why it's under Zoom, or at least that's how I remember that it's under Zoom. So Zoom is up here at the top of your calculator, up here, Zoom. So you're going to hit Zoom, and you're going to go all the way down to number 9, Zoom stat, right? We're doing stuff with statistics. So you can either press the number 9 or you can arrow down to 9. I'm just going to press the number 9. And hey, look at that. Isn't that fantastic? It creates a scatter plot and it draws my line of best fit. Okay. Now, we'll tell you what, let's do one thing at a time. So it's asking us to choose the correct graph below. Okay. So you might look at this and you might say, okay, well, I can tell that this is a positive slope, right? This is a positive correlation. Okay, so right away, I can rule out this and I can rule out this because those have negative correlations. Okay, but you might look at these and you might say, well, hey, they both have positive slopes, right? Positive lines. And you know what? It's just a little too kind of close. Like the dots are kind of too close together for me to really see like what exactly, like where exactly they're located, right? Like I'm not going to be able to tell like the exact values, like the ordered pairs of those points. So what you want to look at is what's going on with my line, right? So this line is going through most of those points, right? This line is way above those points. Well, that's not a line of best fit. A line of best fit is one that goes as much through the points as it possibly can. I mean, it's a little bit more involved in that, but you guys aren't necessarily focusing on that. You probably did have to learn about like, where the line comes from, but they're not asking you to like do the math to create the line yourself. But just know that, if I have, a scattering of points like this, it wouldn't make sense for me to draw a line that looks like that or a line that looks like that. I need to draw a line that goes as much through those points as I possibly can, right? That's not the line of best fit. That's not the line of best fit. The one that goes as much through them as possible is the line of best fit. And that's why this is the choice, not this one. Those ordered pairs, the points themselves might actually be in exactly the same place. I mean, it's a little hard to tell. They're not, but even if they were, that's not a line of best fit. That is. Okay, so now the next thing it wants us to do, which is the last thing that we're doing here, and then we'll be done, is that it wants us to predict values of y for 4 different x values. Okay, so there's a couple ways to do this. You can do it by hand, right? The way that we've been doing it, where you say, okay, here's my equation. I'm going to plug in a value for x, and I'm going to solve for y. You could absolutely do it that way. But since we've got the calculator out, why not have the calculator do it for us? Okay. All right, so once we've graphed it, if you hit trace, that's going to allow you to trace along this line. Okay, so you hit trace, which is right up here. And if I go left and right, well, I guess right, it's going to jump to the different points. Right? So it's highlighting this and it's telling me, hey, that's your data point, your ordered pair 772 and 51. Right, there it is right there, 772, 51. That's my x and y. And hey, here's your point 628, 48. Right, 628, 48, x and y. Okay, well, what if I don't want to look at my scatter plot values? What if I want to look at the line itself? Because that's what we're being asked to find, right? We're being asked to find points on the line, not points that were already plotted, but points that are on this line of best fit. So what you're going to do is your up and down arrows allow you to go back and forth between the data points that have been plotted and the line of best fit. Okay, so I'm going to hit the up arrow and you can see that my cursor has now moved to this line. And now I've got, okay, here's an x value and here's the corresponding y value, right? Lots of decimals because we're using this equation here, right? That's what it's using. Okay. Also right here, y1, that's our equation, right? It's showing me what my equation is. It can't display the whole thing because it's not rounding the decimals here. So what you can do here is you can just type in a number. You don't have to go to any particular field. You can just type in an x value and it will say, oh, well, here's your corresponding y. So when I say just type in, I literally mean you're not, because I think sometimes this confuses people. They're like, well, where was I supposed to go to put in that x value? You don't go anywhere. You just make sure that you are on the line of best fit. And then I want to plug in an x value of 498. So I'm just going to start typing 498. You notice as soon as I started typing, it was like, oh, you're trying to give me an x value? Okay, what's my x value? Okay, so x value of 498, and then I hit enter, and it says, oh, hey, well, that's right here on your line of best fit. This is your x value, and here's your corresponding y value. And if we take that and we round to a whole number, that's how we're getting 41. I know this is hard to see, but it's 40.989465, which if you round that is going to be 41. Okay. All right, so let's do that again, because now it wants, well, what happens when x is 645? What's your corresponding y value? So again, I don't have to like go to any particular field. I can just type in 645, hit enter, and it says, oh, well, that's way up here on your line of best fit. This x value gives you a corresponding y value of this on this equation, on this line of best fit. Okay, so that's 47.004. Well, that rounds to 47. Okay, but what happens when it wants us to do an x value of 310? So I start typing 310 and I hit enter and it's like, whoa, 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 hold on a minute. Attempted to use a variable or function where it is not valid. Well, why is it not valid? Because we're trying to use an x value of 310, but if we look at our x values here, they don't go down that low, right? 310 is significantly lower then this sort of range, and I don't like using the term range because some people get confused, like domain and range, but the range of values here from 483 is the lowest. Yeah, 483 is the lowest X value. 772 is the highest X value. 310 is way lower than that. It's not even close to being in like near these numbers. We can only extrapolate to things that are like near these values, right? It doesn't have to be exactly in it, right? It doesn't need to be like, oh, the lowest I can absolutely do is 483 and the highest I can absolutely do is 772. But it needs to be near it. And 310, right? Is that what they asked for? 310? Yeah, 310. That's way below. That's way below this. Okay. So that's why it's giving me an error, because it's like, that's way too far away from the ordered pairs that you gave me. That's why it's saying that it's invalid, because it's not meaningful. We can't draw meaningful conclusions to something that is so far away. And then the very last one that we have, so I'm going to say quit. Okay, and then I want to go back to that. So how do we go back to that? We want to graph. So we're going to go to second y equals. We go to our stat plot. Right, we make sure that everything is in there. I mean, it was already in there, but just to be sure. Then we go to zoom and we go down to 9. And then it recreates this, right? So now I'm back in the correct window. And now I want an X value of 727 again. I am going to go ahead and arrow up here to, oh, I'm sorry, I forgot to hit trace. I was like, why isn't this doing it? Because I need to trace my line of best fit. So I have to hit trace. Now I can arrow up and down to go between my scatter plot and my line of best fit. Okay, I'm on my line of best fit. Now I can type in 727 with an X. That's going to give me corresponding Y value of approximately 50. Okay. All right. So that is it. 2.5 hours later, that is it. I know it's a lot in these 2 chapters, but just practice as much as you can so that it becomes second nature, and so that all of the steps separately don't seem so overwhelming, right? We just go one at a time. I'm going to type in my email address here. Yeah, so that's my email address. If you emailed me at a different email address in the past, that's fine. It's all going to go to the same place. Yes, Skylar, I will definitely email that to you. And for the people that, well, I guess nobody's watching the recording if they don't already have it. I guess if you're watching this recording and you want me to send you recordings of previous reviews, go ahead and email me and I can do that. And yeah, just keep doing your practice and don't forget to, if it helps you, it definitely helps me to make kind of notes like this about, where do I find these things in the calculator? How do I know when to use what calculator menus, right? These are all really useful. I might do a scan of this if maybe that's helpful. And then I'm not necessarily going to do a scan of this. These were just things that, that come up time and time again. You want to make sure that you feel comfortable with them. And then definitely you got to make sure that you know this part down here. So maybe I will scan this part at least, right? Your decision rule based on your p-values, and then how you're allowed to word your conclusion. And then, some of your symbols. Okay. All right. Well, that's it for today. I hope this helped, and good luck, everybody. All right.